Hello, welcome to Further Academy. In this video, we'll be considering panel data analysis. If you're struggling with analyzing panel data using STATA, this video walks you through exactly what you need to do to analyze panel data. It is worthy to note that there are several techniques to analyzing panel data analysis. We have the fixed effect models, random effect models, pooled regression models, amongst many others. So for the course of this tutorial, we will consider the fixed effect model and the random effect model. Before we dive right into that, I would like to give brief insight into panel data. Panel data is also known as cross-sectional time series data. It is a data set in which the behavior of entities I are observed across time t. Panel data deals with omitted variable bias due to heterogeneity in the data. It does this by controlling for variables that we cannot observe, are not available, or cannot be measured but are correlated with predictors. These entities could be states, families, countries, companies, and so on. Now, the data format for analyzing panel data is also known as the long form. Variables should be in columns, while entities and time should be in the rows. So if you do not have your data set in the long format, you would want to convert it into the long format before proceeding with panel data analysis. Now, it is also important to set our data set as panel before proceeding with panel data analysis. I'm going to import my data set into STATA. I have my data set in the CSV format, so I'm just going to import that. Okay. So now I have my data set imported into STATA. We can view the data set here. So on here, we have the airline, here, cost, output, for price, and load factor. The entity here is the airline, and our outcome variable, the response variable, is the cost in $1,000. And also we have the output, we have the for price, load factor here, airline. All of these are the predictor variables. So let's dive right in. To set our data into panel, all we have to do is to type xtset. What comes next is our entity, so which is airline followed by year. So now we have our output. Balanced panel simply means that all entities are observed across all the time, while unbalanced panel implies that some entities are not observed in some years. So here we have strongly balanced, meaning our panel is a balanced panel, which also implies that all entities are observed across all time. To visualize our data set, all we have to do is to type the command xtline. We have several variables here. We have the cost, output, for price, load factor here, and airline. So we can visualize cost. So here we go. We have a graph for cost for several airlines. We have airline 1. We have the graph here for airline 2, airline 3, airline 4, airline 5, airline 6. So we can also do the same for all other variables. Xtline, output. Here we have the several graphs for output. So we can see here that we have several graphs. So we can decide we only want one graph for output. We only want one graph for cost. How do we do this? All we have to do is to type the command xtline cost overlay. So there we go. Now we have one graph for this. Here we have one graph for this. So we can as well do the same thing for all other variables. Instead of having several graphs, we are just going to have one graph. So here we go. We have our graph for output. This is for line 1, line 2, line 3, 4, 5, and 6. So there we go. Fixed effects help provide more reliable estimates in panel data analysis. Fixed effects are categorized into entity fixed effects and time fixed effects. Entity fixed effects are variables that do not change over time but vary across entities, such as cultural factors, differences in business practices across companies, and so on. While time fixed effects are variables that change over time but not across entities, such as federal regulations, international agreements, and so on. Entities have individual characteristics that may or may not influence the outcome and predictor variables. For example, the business practices of an organization may influence its level of spending. Business practices, cultural differences, and so on are most of the time unavailable or difficult to measure. Since individual characteristics are not random and may impact the outcome of predictor variables, hence we need to control them. This way, the effect of the outcome variables will not be influenced by those fixed characteristics. In entity fixed effect, it is assumed that correlation exists between the entity's error term and outcome variables. However, an entity's fixed effect cannot be correlated with another entity's fixed effect. Here we have the entity's fixed effect regression model, where YIT stands for the outcome variable for entity I at time t. This stands for the unknown intercept for each entity, while XIT stands for the vector of predictors for entity I at time t. This stands for within entity error term, and this stands for the overall error term. If you are to interpret the beta coefficient, we would interpret it as for a given entity, when a predictor changes 1 unit over time, the outcome will increase or decrease by beta units. So assuming we have a negative value, would say that the outcome will decrease. When we have a positive value, we say that outcome will increase. Beta represents a common effect across entities controlling for individual heterogeneity. Now, to obtain the pooled data, which is a combination of all observations across variables and time into a single data set, is very simple. All we have to do is to type sum, then we type the several predictor variables where we have the cost, outputs, for price, and load factor. So now we have the output. So here we can see that for the variable cost, we have 90 observations. Same as the variable named output, we have 90 observations. For price, 90 observations. Load factor, 90 observations. And here we have the mean, standard deviation, minimum, and the maximum values for all of these variables. So now we'll proceed. Also, we can as well get the heterogeneity by panel and time. All we have to do is to type xt sum. Command for the heterogeneity by panel and time is almost similar to the command for the pooled data. So all we have to type is the xt sum, cost, outputs, for price, and load factor. So here we have the heterogeneity by panel and time. Proceeding further, it is worthy to note that before proceeding with the panel data analysis, we would have to log transform our variables using the lin function. It is very important to log transform our variables, as we would not be able to proceed with the panel data analysis without doing this. So to log transform our variables, all we have to do is to type this command gen lin output. So this lin output is the name. So I'm going to be having a new variable. So the lin output is the new variable name. You can feel free to name your variable as you wish to. Equal lin output, which is the previous variable. So now we already have another variable generated, which is the lin output. We would also have to do the same thing for the other variables. So we have to do that for the fuel price. We have to do the same thing for the load factor and the cost. So then load factor. If you are yet to subscribe to this YouTube channel, kindly subscribe so you can always be notified whenever we upload new videos. Thank you. So we now have 4 new variables that has been generated. We can now proceed. For this data set, none of our variables contain a negative value, so that do not apply to this data set. So if we have a data set, we have variables contain negative values. When log transforming the existing variables, we'll have to have an addition. So for instance, let's assume that we have a variable named fuel. When log transforming this, we'll have to add a number to this variable. So for instance, if the minimum value under this variable is -2, we are going to add 3 to this. Automatically, wherever we have -2 under the for variable, this is going to become 1. So the lin function of 1 is going to give us 0, and we can now proceed. It is very important to do this before proceeding. Now our variables have been log transformed. We can as well visualize these variables using the hist command. So we can have an histogram using the hist command. All we have to do is to type the hist command. Now we have new variables, which is the lin output. So here we have an histogram. So here the histogram, the graph. We can as well obtain a graph for all other variables such as the cost, the lin cost, lin floor price, and lin load factor. So let's proceed. So to do this, all we have to do is to type xtrect, then we go in first with our outcome variable, which is cost, then cost. We're making use of the log transformed variables for this. After the outcome variables, we can now go in with our predictor variables. We'll go in with our predictor variables, output, for price, load factor, then comma fe robust. So here we have our output, where lin cost is the outcome variable, just as I said earlier. We have lin output, for price, and load factor as the predictor variables. Fe here stands for the fixed effect option, and robust here controls the heteroscedasticity. Here we have the number of observations, 90, which is the total number of cases. We have the number of groups, which is the total number of entities. We have 6 entities here, Our entity here is the airline. So we have 6 entities, 6 different airlines. Correlation here, which is minus 0.3494, stands for the correlation between within entity errors UI and the regressors in the fixed effect model. Probability greater than F is the F test. The F test is used to see whether all the coefficients in the model are jointly different than 0. When the value here is less than 0.05, we assume and we conclude that our model is okay. So here we have the probability less than 0.05. We can now conclude that the model is okay. So here we have the coefficient. This coefficient indicates the change in the output. Here we can see that the change in the cost is 0.9187035 as the output changes 1 unit over time. A unit change in floor price will result in 0.4158084 change in the cost, while a unit change in the load factor will decrease the cost by 0.55273005. So here we have the constant variable. Then row here shows how much of the variance in the output is explained by the difference across entities. So now we'll proceed to the entity and time fixed effect regression using xtreg. So to get this done, all we have to do is to type in xtreg, then followed by the outcome variable, after which comes the predictor variable. Then here, after which we type I dot here, because we want this to treat the here, which is the time, as a factor variable. So that's the reason we are adding I dot here. Then can now run this. Here we have the output where link cost stands for the outcome variable. In output, link for price and link load factor stands for the predictor variables. I dot here stands for time fixed effect. FE stands for the fixed effect option, and robust controls the heteroscedasticity. The number of observations is the total number of cases. The number of groups is the number of entities. Here we have the correlation that exists within entity errors UI and the regressors in the fixed effect model, which is 0.3389. So these are the coefficients for the predictor variables: 0.814453. Probability greater than absolute value of t is the p-value test, and value lower than 0.05 will reject the null hypothesis and conclude that the predictor has a significant effect. But for values greater, we can say that outputs do not have significant effect on the total cost, while floor price and load factor has significant effect on the total cost. So in a situation whereby we have multiple numbers of fixed effect or a large number of panels and xtreg command cannot run due to the number of panels, we make use of the reg hdfe command. So we'll be working on this. It is also worthy to note that you have to install several packages into STATA before you can make use of the reg hdfe command. So firstly, we have to install the reg hdfe command. So to do this, all we have to do is to type sst install reg hdfe. So after typing this command, we run it. I already have the reg hdfe package installed on my PC. After installing the reg hdfe package, the next thing to do is to install the ftools package. So all we have to do is to type sst install ftools. So after installing these two packages, you can now proceed to making use of the reg hdfe command. So to do this, all you have to do is to type reg hdfe, after which comes our outcome variable, which is link cost, lane output, for price, and load factor. Then we'll have to type absorb airline, which is our entity. Our entity goes in here, vc loader, then our entity. Then we can now run this. So here we have our output where link cost is the outcome variable, just as said earlier. In output, for price and load factor, the predictor variables, is the fixed effect option, while this is for controlling correlation within panels. Here we have the total number of cases, 90, and here we have our f test. Whenever this is less than 0.05, the model is said to be okay. Here we have our r square, and r square shows the percent of the variance in the outcome explained by the model. Also, we have the adjusted r square, which accounts for the number of variables and their significant contribution to explaining the variation in the output variable. We also have the entity and time fixed effect regression using reg hdfe. To do this, all we have to do is type in reg hdfe link cost, which is our outcome variable, then go in with predictor variable, then output, for price, then load factor, then absorb a line, which is our entity, then here we see register a line. So here we have our output for the entity and time fixed the first. Lane cost is our outcome variable, lane output, lane fall price, and lane load factor are the predictor variables. Here is the fixed effect option. This is for controlling the correlation within panels. Then here we have total number of cases. We have the F test here, and as you can see, the model is okay as value for F test is less than 0.05. Here we have our R square 0.9984 and our adjusted R square 0.9978.